Good afternoon, my YouTube viewers. Crystal here. What I wanted to do this afternoon is I wanted to give you the solution to the analytics VidHaya recommendation engine. I had worked on this previously, but it had caused the system to crash, and I put it away, and I decided to get it out and work on it some more. And when I got it to work on when I worked on it the second time, I was able to get it to work without crashing the system. So since I was able to get the Analytics VidHaya website on the recommendation engine to work without crashing the system, I wanted to make a video on it to show you what I have done. So this program is on the GitHub site, so you can see on YouTube, you can see my name and you can see the repository that it's on. So you can always welcome to call up the repository and go through the solution with me if you want. What I used was a HistGradientBoostingClassifier because this was a very large data set, and because it's a very large data set, the HistGradientBoostingClassifier was the most appropriate classifier to use. The first thing I'll do is I'll go over the problem statement with you. The problem statement states, online judges provide a platform where many users solve problems every day to improve their programming skills. The users can be beginners or experts in competitive programming. Some users might be good at solving specific category of problems, e.g. greedy, graph algorithms, dynamic programming, etc., while others may be beginners in the same. There can be patterns to everything, and the goal of the machine learning would be to identify these patterns and model users' behavior from these patterns. The goal of this challenge is to predict a range of attempts a user will make to solve a problem given user and problem details. Finding these patterns can help the programming committee as it will help them to suggest relevant problems to solve and provide hints automatically on which users can get stuck. Okay, so I know you can't see this. But I'm going to go into the Analytics VidHaya website, and what I'm going to do is I'm going to go into the recommendation engine and look at it very quickly. And unfortunately, I didn't call it up before I started this video, so I'm going to have to talk to you while I'm calling it up. So I'm in the recommendation engine now, even though I know you can't see it because of the way my screen recorder works. And I've looked at my submissions. My submissions was with the HistGradientBoostingClassifier, I got a 0.4197. Now on the leaderboard, the best score on the leaderboard was 0.5113. So that means that I was, 10 percentage points below the highest score. So that's not too bad. I mean, I never professed to be an expert. I'm trying to improve my skills, but I never professed to be an expert. And generally, what people do in order to get these really good scores is sometimes they'll do something called like hill walking, where they'll just like train the test set, and they'll write a program to get the test set to be perfect. But what Analytics VidHaya does is they make you submit the code. If you actually want to submit the competition, they make you submit the code. But I don't actually enter the competition because my scores aren't high enough. So I put the code in the solution checker, and then I check my score on the leaderboard. But because my score isn't high enough, I don't bother to enter it. But, who knows, maybe one day, maybe my programming will improve and I will be able to win a competition. Who knows? That's my goal, is to win a competition. So after I have loaded the libraries, as you can see, what I've done is I load the test files, all of the files that we've been given. And you can see we've been given 1, 2, 3, 4, 5 files. So we have to load all these files up. So we see the train file. The train file only has 3 columns and an index. And then we load the user file, and the user file has 11 columns. We load the problem file. It has 4 columns. And then we load the test file, which has 3 columns as well. The train file has 3 columns. It has the attempts range. So all of these different files have different columns. And you're thinking, well, what am I going to do? What am I going to do with all these different columns? I don't know what to do. Well, what you do is you merge the files together. And that's what I've done here. I did data train equals train merge user on user ID on the left, and then merge problem on problem ID on the left. And then so I called up data train, and you can see all of the columns are now on this one file called data train. The next thing I've done is I took the data train, and if you'll notice, I want to show you something. This is your test file, and this is your ID. It's a combination of the user and the problem, and this is your train file. It's the user ID and the problem, so it's not a combination. So what you have to do is you have to add the data train ID column to the user ID. So you've got user ID plus a little underscore plus a problem ID, and then that gives you your ID column. And so that's right here. You can see that we made the column right here by adding these 2 files together. Because you're going to need to do that, because you need to make sure that you have the same type of columns in the train file that you do the test file. And the reason why you have to do that is because you're going to train the train file, but you're going to test on the test file. So the test file and the train file have to have pretty much the same type of information. So what we did with the test file is we merged the data sets. So we merged the test data set the same way that we merged the train data set. So data test equals test.merge user on user ID to the left, and merge problem on problem ID to the left. And so you can see now we've got data test, and data test is very similar to train test, which is what we wanted. So now what we do is we check to see if there are any null characters, and you can see that there's tons of null characters here. So what we have to do is we have to replace all of these null characters. That's the only thing that we can do, because the computer program is not going to work if you have null characters. So we replace the country with no mode. We replace the tags with mode. We replaced level type with mode. And we replaced point with median. And I do think that what I did was I did the KNN imputer. And on the points, I wanted to see if I would get a better accuracy if I used the KNN imputer on the points column, but I didn't get better accuracy. So in the end, I just didn't use the KNN computer, because I tested it with the KNN computer and without the KNN computer, and I got better accuracy with median. So that's what I decided to use. And then after we replaced all of the null characters, we did another test to see if there were any null characters. And no, there are not any null characters. The next thing we did is we wanted to pre-process the data. So we created a pivot table on with the index on ID and attempts range, so you can see how many how the temps range related to the IDs, and every row had its own ID. And then what we did was we did a group by on the attempts range. So you can see that there were 6 different attempts ranges available, and you can see that you can say basically all the information available on the 6 different attempts range. And then what we wanted to see was we wanted to see a graphical representation of the attempts range, because a lot of people like to see pictures. So this is your picture of your attempt range, and you can see that number 1 was the highest, 2 was the second highest, and then it kept decreasing as you got down to 6. So we did a group by on submission count. So this tells you how many submission counts they did according to the attempt range, and we summed it. And then we did a violin chart, so you can see most of the information was in the lower end of the scale, like between 0 and 1 or something like that. And then as you can see that as the numbers increased, the sums decreased. So we did a group by on problem solved, and so you can see how many problems were solved and how many attempts were made to solve the problems. And then what we did was we did a violin chart on that as well, and that violin chart is very similar to the previous violin chart. It looks very, very similar, almost exactly the same, really. So what we did was we did a little bit of programming here. So data train percent solved equals data train problem solved over data trained submission count. So what I was trying to do was I was trying to reduce the number of columns that I was going to put in feature selection. So I made an extra column called percent solved, and I took problem solved over submission count to give you a percentage. And then I made it an integer. So I set it up to where the percentage only had 2 decimal points, and then I made it an integer. I did that on the data train file and the data test file. And so you can see the output that we had after we had our integers. So we did a group by for this, for the percent solved in the attempts range. And so we had 70 different numbers, 70 different possibilities after I made it an integer. And, I put it in decimal. I decimalized it, and then I made it an integer. So that was 70 different possibilities, which was going to reduce the number of tests that the computer was going to have to make, and hopefully meant that it had to do less work, and hopefully give it a higher accuracy, because that's what the name of the game is. The name of the game is getting a higher accuracy. And so we did another violin chart with the percent solved, and you can see that the percent solved is in the higher end of the range between 80 and 100%. Now we did contribute, and your contribution had negative numbers and to positive numbers. We did a violin chart of the contribution, and most of the contributions were close to 0. So we also did a group by on the country, because we wanted to see which countries were involved in this, and we had 79 different countries that were involved in this project. So what we did was we put the country data in a label encoder. So every country was assigned a number, and we did a group by, and you can see in this instance how every country was assigned a number. So we did a violin chart, and you can see that some countries were more active than others. So what we did now is we did a follower count, and we did a group by on that, so you can see how many followers every person had. The next thing we did was we did time online, and I experimented with time online because at first I said days. I wasn't, it was data train time online. That was a new column that I made, equals data train last online time seconds minus data train registration time seconds. So I experimented with that, and at first I divided it by 60 times 60 times 24 to make days, and then I divided it by 60 times 60 to make it hours, and then I divided it by 60 to make it minutes, and then I just didn't divided it all, and I found out that you had a higher accuracy if you just didn't divide it at all, and I made the number in integers. So we did another group by on the time online, just so you can see it. So in the end, I didn't really manipulate the data at all, except for to say that the time online equals last online time seconds minus registration time seconds. So we plotted a violin chart, so that tells you that most of the time online, it gives you a representation of most of the time online. And then what we did was we created an extra column called rating diff equals trained data max rating minus trained data rating, because what we were looking for is we were looking for the difference. And then after we did that, we made it an integer and we printed it off, and you can see the difference between the max rating and the rating. We did a group by, and you can see that after we plotted the difference, there were 192 choices. We did a violin chart on that, so you can see how the difference relates. The difference was more at the lower end of the spectrum. Then what we did was a group by on the rank, so you had beginner, intermediate, advanced, and expert. We did a graphical representation of that, so you can see intermediate was the highest, and then beginner, and then advanced, and then expert. So we put that on a label encoder, and so everything was assigned a number. And then after everything was assigned a number, then it was put in a format that the computer can see. The next thing we tested was level, and so you've got the level type and the intense range. And again, these are characters, and the computer wants to see numbers. But what we did was we did a graphical representation of this so you can see it. So A is the highest, going all the way down to N, which you can't really see anymore. So we put the level type on a label encoder as well, and you can see we did another group by on that, and you can see that this was instead of letters, now it's integers, which is what the computer wants to see. Now we had points, and we did a group by on that, so you can see all the points awarded. So there were 29 different points that a person could get, and we didn't do anything with that. And so now we had tags, and the thing about tags is tags was a CSV. It was comma separated values, and so it was only one column, but it had different information in the one column. So what we had to do was we had to separate this out into different columns, and we had to separate it by the comma because it was comma separated values. And then what we had to do was we had to assign 7 columns. So the columns were tag 1, tag 2, tag 3, tag 4, tag 5, tag 6, tag 7. So you can see the different columns. We did that on the test set as well, because the test set and the train set have to have the same number of columns. If they don't have the same number of columns, then it won't work when you go to test it. It won't work. So you have to make sure that the train set and the test set have the same number of columns. So what we did is we did a test to see how many null characters were in tags train and tags test. There were loads of null characters. And so what we did was we replaced all of the null characters with a comment saying no tag. And then what we did was we took all of these tags and we put them in a label encoder. And so the text values were label encoded. So now you can see that in these tags, instead of having a word, you actually have an integer, which is what the computer wants to see. So now what we had to say was we had to create another file called combi-train and combi-test. Combi-train equals data train merge, tags train, left index true, right index true. And combi-test equals data test merge, tags test, left index true, right index true. So now what we had to do is we had to merge combi-train to data test. So here we go. And you can see at the end of the table, you can see you've got tag 1, tag 2, tag 3, tag 4, tag 5, tag 6, tag 7. You also have the extra columns that I made, such as ID, that was a column I made, percent solved was a column I made, time online was a column I made, rating diff was a column I made. The same thing with the test, you just want to make sure it's all there. And then the next thing we did was we did feature selection. So we assigned our features. We assigned the columns that we want the model to train on. So the columns that we selected were country, follower count, rank, level type, points, percent solved, time online, rating diff, tag 1, tag 2, tag 3, tag 4, tag 5, tag 6, tag 7. The next thing we did was we defined our X, Y, and X test values. Y is your train attempts range. X is combi train features, and X test is combi test features. So you wanted to see what was in Y, so you can see what was in Y. You wanted to see what was in X, so that's country, follower count, that's just all your features. You wanted to see what was in X test, and again, that's all your features. The next thing we did was we used something called SMOTE because there was an imbalance in the answers. There was an imbalance in Y of train attempts range, so we used something called SMOTE. And then after we used SMOTE, we split our data test up into X train, X val, Y train, Y val equals train test split, X resampled, Y resampled. I set a train test of 0.1 and a random state of 1. You wanted to see what X train shape, X val shape, Y train shape, Y val shape, and you can see that now you have more rows than you previously had, because what they're doing is when you use SMOTE, then what it does is it assigns synthetic sampling to it to try to increase the level. We also used a standard scaler. I tried the model with the standard scaler and without the standard scaler, and it worked better without the standard scaler, so I didn't use it. we decided we were going to use the HistGradientBoostingClassifier. I tried using it on the MLP classifier, but I got a better answer. I got more accuracy on the HistGradientBoostingClassifier, so I decided to use that. So we had a score of 50%. Okay, y_pred equals model predict xval, print model score xval yval, and that was 48%. So we had to check the F1 score and the recall score, which was 47% and 48%. So we wanted to print the tunable parameters, which we did. We created a confusion matrix so you can see all the values that were in each category of the output. So we checked the accuracy, which was 48%. We produced a clarification report. You can see the clarification report. And so we checked the data frame to compare the actual values against the predicted values so you can have a look and see for yourself. We checked the accuracy of that, and it was 48%. Now what we did was we had to test the test set, and this is your outcome of your test set. And so obviously we don't know what the outcome is because Analytics VidHaya has that. And then we put the outcome into a data frame with the ID was test ID and attempts range was test pred. And then we created a file called submission.sub, and we downloaded that. And then once we downloaded it, we submitted it to the Analytics VidHaya website, which I know you can't see that, but that's what we did. And I got about a 41 percentile. Let me just check again. Which was about 9 points lower than the highest percentile. So it wasn't too bad. And so I just thought, well, I'll stop here. I'll stop here. And obviously I can't formally enter the competition because my score isn't high enough, but this is a solution. And then I used all of the appropriate data science techniques. I think the only thing that I could have done, I don't know if you can do it, but I could have investigated to see if I could put it on a grid search, and putting it on a grid search may have increased my score a little bit. But this HistGradientBoostingClassifier is an experimental model that I got from the sklearn, but I'm really happy with it. It gave me a better score than MLP classifier. So that concludes it for this solution. If you like my solution, then please like, subscribe, and share. If you like the work I do and you want to leave a donation, I've got my email address to my PayPal account down below. I would just like you to know that I've also got an account with Medium, so I'm going to start making blog posts on Medium as well. But I don't have enough subscribers on YouTube, and the only way I can make money is to actually ask for donations. So that's why I'm doing that. And thank you so much for watching this video, and I look forward to the next video. I look forward to showing you the next video.